Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are beginning our project of building a jigsaw puzzle in Unity with Bolt, visual scripting. So join me in the Unity Hub, or just open up Unity if you're using the Unity application instead of the Unity Hub. And we're going to create a new project. So via the Unity Hub, you're going to select the New button. Then we can choose a template for our project. We're going to do 2D because our jigsaw puzzle will be two-dimensional. Let's give this project a name. We'll call this Jigsaw Puzzle. And then choose a location for your project that you can easily find. All right, then press Create, and that is going to launch for you the Unity editor. And here we have our project. You can see the project folder, which contains all of our content and the hierarchy. All we have is our scene with a camera. If you press play, you can see what your game looks like without any changes to the template. It's just this blue screen. Note that the first time you load the project and the first time you load the game, it can be a little slow. It can take a few moments to load all of its components, but after the first time, it'll be much faster. All right, so let's go ahead and get started. We're going to create our board. Let's go into our sample scene, and we're going to add a new empty game object that we're going to call our board. And we're going to generate tiles for the board with visual scripting. So if we want to add a script to this board object, all we have to do is add a component to it here, and the component is a script machine. Okay, there we go. You'll notice you get variables and a script machine component. Here you can add a new variable if you'd like, new variable, and just press the plus button and then give it a type and a value. And you can use these variables in the script machine. And you can remove the variables at any time. Now, to create an actual script via visual scripting, here you can either create a new script asset, or you can embed a script asset. If you embed a script asset, it means it's attached to the object, this board. And you can access it by going to this board object. If you make it a graph, it means that it's going to be a standalone graph that you can reuse. So it's up to you what you want to make the script. Let's just make this embedded, and I'm going to call this Generate Board. Then if you want to edit the graph, you just press that button, Edit Graph, and this will take you to the script graph. Okay, and if you want to make this full screen, you can either use the button in the top right-hand corner, Full Screen, or another option is just to double-click on the script graph text here. In the top left-hand corner, we have a lock icon to lock the graph in place. We also have an eye icon, which shows you information about the graph here. You have the name, the summary, trigger inputs and trigger outputs, which is what the graph can take in and out, and also data inputs and outputs, which are like values. If you're familiar with coding, this would be the equivalent to passing in a parameter and returning a value. Then the next icon we have here contains the different variables, so you can hide the information at any time and open up the variables here, the blackboard. First, we have graph variables, which can be used only in this current graph. We have object variables that can be used anywhere on this game object. We have scene variables that can be used anywhere across the scene. Application variables can be shared across scenes, and they'll be reset when the application quits. And finally, we have saved variables. These will persist even after the application quits. All right, so there we have those three icons at the top. They'll prove useful. And next we have the name of the actual graph. You can have subgraphs, and you'll see each subgraph appear. We'll be doing that later on. You also have zoom. You can zoom in and out with this tool. Then in the top right, we have relations, which will show you whether you want to show the relations or not on your graph. So let me just hide my information here. Okay, you'll notice if I click relations, these lines, they disappear. You can also choose whether or not you want to show values, dim, carry. You can also grab an overview and change it to full screen. Those are the main tools of using your script. Let's go ahead and remove the update event, because these two events, they're the equivalent of the start and update functions in C# if you've ever coded. The start event is going to execute some of its tasks as soon as the application or this graph is instantiated. So as soon as the graph comes to use. Typically, that is when the play button is pressed or when an object is spawned. Then we have the update event. This is going to be called every tick after the object or application has been spawned. So first will be the start event, and then update runs every tick, which means every frame of the game. We can remove update because for the board, we only need to generate our tiles the one time. As soon as the application begins, we are going to generate the tiles for the board. So let's get started. Let's take this start event and let's drag off a node from this green arrow here. This is an executable node. It means we want something to happen after the start event. So I'm just going to click and drag here, and I'm going to select what I want to happen. And you'll notice you have these options for units. You have board options, which refers to the object. We have the code base. We have collections. We have control, as well as events. Then we have math. We have nesting, nulls, time, and variables. Okay, so here are all of the different units that we can put together. For example, in collections, you can go into lists and you can see all the different functions for lists, such as adding an item to a list. You also have the code base where you can access different assets. At any time, you can search for a unit. For example, I can search for a for loop, and it will pop up at the top. Then I can just select that for loop. Let's see, there you go, hit enter, or just click on it and you'll get this for loop node. And notice that it's connected to the start event. If you want it to happen after the start event, you have to connect it via those green arrows. We're going to make a for loop and then make a nested for loop. And what we're going to do is loop through every tile space on the board, and we're going to spawn a tile at that space. All right, so if we go back into our visual here, back into our scene, we'll be able to see that if we zoom in, we can see the white outline of our board. And we can see that inside of the board, we have these different squares to mark off sizes. So each of these squares, that represents a position inside of the game, and each of these is exactly 1 unit long. So we're going to have each puzzle piece and each tile in the board be exactly this 1 by 1. You'll notice it's kind of imprecise where it begins, so all you have to do is just change the location of your main camera. All right, so just use in the top here the arrow tool and just drag that main camera so that it aligns with one of the tiles perfectly here. Same for the top and bottom. So let's just go to the top here and we can make sure it aligns. Okay, great, it does. You can also change its size as well, because you'll notice it goes off a little bit off screen. So in the game here, you can change your window aspect ratio, because you'll notice here by default you'll typically have free aspect, but you can make your own custom resolutions here. If I add a plus here, I can make my own. I can call this a phone. I can either do fixed resolution or aspect ratio. For example, if you want to do a vertical phone, you just have to set the X to 9, the Y to 16 and press OK. And that will be saved throughout your different projects. So that's why I had one here already for my previous project. Okay, so now we have that resolution, and for mine it doesn't change, but for you likely your resolution was just free aspect. That can typically be the default, but then you can make your own. Because we want to mimic a mobile game, therefore we want this phone. Okay, back in the scene here, we can now see we have our screen aligned on the left and the top, horizontally and vertically. Okay, we can also count how many tiles we have. So we have 1, 2, 3, 4, 5 tiles. And then we do have 1/2 of a tile on the side. So what we can do is just position this in the center. Move the camera over a little bit. So let me just hide this. Let's see. Okay, I'm going to click on the camera and just double click on it to center it and go back to it. Then here, I'm just going to move it so that my camera or the outline of the board is centered. Okay, there we go. Great. We also want to make sure that one of the positions is at 0, 0. Typically at the bottom here. This should be 0, 0. And we'll test that shortly. Okay, back in our script here, we'll notice we're looping from 0 to 10. Okay, so we can change this to be how many tiles we want to spawn horizontally. In this case, 5. Why do we put a 5 there? Well, because if you go to your camera and you see, you count the number of tiles. You have 1, 2, 3, 4, 5 total tiles horizontally. Okay, so we have 5 full tiles on one row. That's why we put a 5 there. Okay, this for loop is going to execute starting at 0 and then ending at 4 because this 5 is exclusive. So if it loops from 0 to 4, it's going to go 0, 1, 2, 3, 4, which is 5 tiles that it'll create. Then we also have to do it vertically, so it creates 5 times however many tiles we have on the rows. Let's just extract this 5 into a variable because otherwise we're leaving it here as a 5, which can be confusing. So I'm going to just drag a node off of that last parameter here. And I'm going to search here for a variable. Okay, and you'll notice here we can get variables or set them. Currently though, we don't actually have any variables. So let me just hit escape to remove that node and let's create a variable. So I'm going to go into our Blackboard icon here and you'll notice we have different options for variables. I'm going to choose here an object variable. So it's going to be shared across the board game object. Okay, then I'm going to enter a variable name first of all here, and let's call this our horizontal tile count and hit plus. Then the type here is going to be an integer. You'll notice types are color coordinated. All right, so and make sure you select integer so that you have this turquoise color which matches up with the turquoise here parameter. An integer is a whole number. The value here that we're going to select is 5. Okay, so then I can just drag and drop that right onto my scene here, into my graph. Okay, let me just hide that. And here you'll notice we have this node called getVariable. The type is object. The name is horizontal tile count, and it exists on this game object, the board. Whenever you see this, it refers to whatever object the graph is attached to. All right, then I'm going to connect this node because currently it's unconnected, which means it's never going to be performed. But I'm going to connect it to that last parameter. So now instead of using a 5, I'm using a variable, and that just makes it much cleaner and easier to understand because otherwise someone could look at your graph, or even you in the future could look at your graph and you could go, what does that 5 mean? I totally forgot. Okay, so that's why it's useful to create variables. All right, so currently we're looping from 0 to 5. Okay, next we want to loop vertically as well. So let me go back into my scene here. Okay, and you'll notice here we have 5 tiles in each row, but what about the tiles for each column? So let's count here how many we have. If I zoom in, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so I have 10 total pieces here going vertically. All right, so that means I have to loop not only here from 0 to 5, but I also have to loop from 0 to 10. So that way I fill my whole board with tiles. Okay, so for this, we're going to go into the body of our for loop, because a for loop is going to perform some action on repeat. And I want it to perform not only looping from 0 to 5, but then also at each of these row numbers. So at each of these tiles, because currently it's just looping from 0 to 5. So it's going to go 0, 1, 2, 3, 4. All right, but then at each of these, I also want it to loop vertically. So I want it to go not only through each of the columns here, because we have 5 full columns, but I also want to go through each of the 10 rows. All right, so here I'm going to go into the body and I'm going to create another for loop. Right, then hit enter. And this time I'm going to loop from 0 to 10. Okay, so that is going to go through all 10 of the rows. So first we're looping through all 5 of the columns, which is the horizontal tile count. Then we want to loop through all of the rows, which is the vertical tile count. How many tiles are there vertically? Let's create a new object variable for the vertical tile count. You can hit enter, then select here an integer and give this a value of 10. Then we're going to drag and drop that variable onto the graph. Okay, and here we're going to connect the variable into the last parameter of this second for loop. Okay, so now we have 2 for loops and these are nested. So we have one and then a second one is nested inside of the first. Why is the second one nested inside of the first? Well, because it's connected through the body. Okay, next, what do we want to do at each tile? Because now we're starting at our 1 tile, we're then going through each row and we're going through each column as well. So we made a loop that is going to go through every single open position on our board. Now, how do we actually create a tile at each position? Well, what we can do is use the instantiate function or the instantiate node. So off of this for loop body, here I'm going to drag another node and I'm going to search for instantiate. Okay, and you'll notice here we have different options. We can instantiate with an original, which means the prefab or what you're instantiating, a position and rotation. You can also specify original, position, rotation, and parent, or the parent object where you want to put the clone. You can just spawn an original without any arguments and more. So you have a lot of different options. I'm going to select here my second option. So I want to instantiate a new component here. You can also instantiate game objects, as you can see below. These are quite similar, instantiating a component versus instantiating a game object. Okay, so I'm going to choose component here and choose my second option here. I can choose the original, the position, the rotation, and the parent. So I'm going to hit enter and you'll see this component available for me. Okay, so let me just drag everything a little bit closer together. Here, first we need to pass in some original. So we need to create a prefab or a reusable object for a tile that we can spawn over and over again. So let's go back into our scene here. And we need to create, in our scene here, we need to add some kind of tile object that we can reuse. So let's go to the hierarchy and press the add button. Here we're going to add a new 2-dimensional object because this is a 2-dimensional game. It's going to be under sprites, and here let's choose a square. This will spawn a white square on your board. Okay, and we can call this our tile. Now you can click on the arrow tools and drag these around, and you'll notice the tile is actually an exact fit for the board, and that's just the default size of a tile. You can also resize it, of course, but we want to keep this the default size so it'll be really easy to spawn these tiles at a certain position. Okay, so now we have one tile, but we have to make this reusable. We have to make it into a prefab instead of an object in our scene. So let me just drag the hierarchy out a little bit. Just put it here. That way I can drag my tile from my hierarchy into my project folder. So first let's right click in our assets folder and let's create a new subfolder to stay organized. And I'm going to call this our prefabs folder. Then I'll double click to enter it. This is going to store all of our reusable objects. Then I'm going to click on the tile in the hierarchy and just drag it and drop it into the prefabs folder. You'll notice by doing this in the prefabs folder, we now have tile.prefab. And also in the hierarchy, the tile has now become highlighted in blue. You'll see it's now not just text in white, it's actually highlighted in blue because it's now a prefab. Because it's a prefab, I can delete it from my hierarchy here and it'll be removed from my game. Okay, and then I can put it back in anytime just by going into my project folder here and just dragging it right onto the game. And look at this, I can create multiple instances of a tile. So we could do this manually, but we're going to do it via our graph. We're going to fill the board with these white tiles. Okay, and here, if you double click on this tile prefab, you can actually open it and you can see the prefab view. You can also drag out your inspector here on the right hand side. The inspector window, also at window, and then you can find the inspector. Okay, so here you can see different information about the tile. Like you can see its position, you can see its color, and if you make a change here to the prefab, like if I change the color of my tile, let's say I change it to something like an orange. Okay, let's just give this an orange color. If I change my tile to orange, because this is a prefab, every time I now create a new tile, it will always be orange. So it's a way to have your changes be saved and reused instead of having to change each tile individually. Okay, so let's just undo that with Control Z, and you can just bring this back to a white color. All right, great. So now we have our tile object, which means in our script here, we can now instantiate the tile object. So let's continue this project in the next lecture. We're almost finished with this graph. And coming up next, we are going to instantiate the tile at every free spot on the board. So I will see you in the next lecture. Hello everyone and welcome back to our course. In the previous lecture, we set up our board graph. Here we have a for loop and a nested for loop, and we're going to instantiate a tile at each open position on the board. So first we need our original object, which is the prefab that we're going to use to instantiate a clone of. So here we're going to select our tile. You can search for this. Make sure you select the tile from the assets folder, not any tile in the scene folder. If you have a tile in the scene folder, this is a temporary tile. You want to use the one from your assets folder, which is from your project folder. Because let's say I use a tile that's on my board, well then at any time, if I delete that tile from my board, then I'll no longer be able to use it in the graph, and the graph actually will break. Okay, so that's why we have to make sure we're using a tile from our assets folder. Next, we need the position of our tile, which is where we want to spawn the tile. Now, we're actually going to be spawning 5 by 10 here tiles. So let's see, in total, that would be 50 tiles. Let me just make sure we have our count correct. 1, 2, 3, 4, 5, 6. Okay, then we have 7, 8. Let's see. I can just go to my board and let me just make this a lot bigger. There we go. Now I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yes, so I'm going to have 5 by 10 tiles, which means 50 in total. So all of them cannot have the same position. Each of them needs a unique position. So how do we figure out where to spawn each tile? Well, luckily for us, we have here an index at each of the for loops. Okay, so we can use our index for the row as our X position and our index for the column as our Y position, because we'll have indices 0 to 5 and then 0 to 10, exclusive of the last value. So really 0 to 4 and then 0 to 9, which in total is 5 by 10. Now, if you go into your scene, you can actually add a tile and you can see its position. Okay, so let's go to our project folder and put a tile at the bottom left-hand corner. All right, then let's go into our inspector and let's see what the position of that tile is. Okay, so it's about -2 and -4.4. So I want to change this to 0, 0 because 0, 0 is going to be the starting position for a tile. Then my next tile is going to be placed right beside it. And right beside it is going to be actually 1, 0. So you'll notice here we have 0, 0, then we have 1, 0. The next one will be 2, 0. And then if I put 1 on top, it will be 0, 1. Okay, these are averaged, or these are rounded, but you can just round them right up to 0, 1. Okay, so we have to actually move our camera so that this position here of 0, 0 is the bottom left-hand corner, because all the tiles will be spawned above that. Okay, they'll be spawned from 0, 0, and then to 1, 0, and then to 2, 0, then to 3, 0, and 4, 0, and then it'll go from 0, 1 to 1, 1, to 2, 1, to 3, 1, and then it will go from 0, 2 to then 1, 2, 2, 2, and 3, 2. So it'll just keep going up. So I'm going to just make sure I move my camera. So let's go into our hierarchy and select our camera. Here I'm then going to use the arrow tools and I'm going to drag the camera. Okay, so I want to move this camera object up until its bottom left-hand corner is that 0, 0. Okay, so you can move your camera anywhere. It doesn't have to be in a fixed position. We need to move it so that the bottom left-hand corner matches up with our 0, 0 tile. Okay, and it doesn't have to be perfect. It can just be like this. Great, okay, so that means 0, 0, that will be the starting position, and then it will create 5 on each row and 10 on each column. Okay, so let's just delete all of our tiles, and now we can go back to our script, and we can put this to the test. So we have to create a new position. A position is a vector 3 type, which means it has 3 values on the X, the Y, and the Z. All right, so we have to create a new vector 3 for each of our tiles. I'm going to right click anywhere in my graph and I'm going to search for vector 3 and then I want create. I want to create a new vector 3 that can take in X, Y, and Z parameters. That's why they're in those parentheses. Hit enter and you'll get this node here called vector 3 create, and it takes in X, Y, and Z values and it returns a vector 3. The value it returns is going to be passed to our position for each tile. Now, what should the X, Y, and Z actually be? Well, the X should be the index that we're currently at horizontally. Okay, so I'm going to drag the index from the first for loop and pass it to the X because we're using the horizontal tile count from 0 to 5, exclusive. And so that will be the X position. The X position for each tile can either be 0, 1, 2, 3, or 4. Next, we have the Y, and that's going to be the index from the second for loop. Okay, there we go. And why is that the Y? Well, because this second for loop goes from 0 to 10 exclusive, which means that its index can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So each of our tiles can have a Y position of 0 to 9 inclusive. Then the Z position we can keep at 0. If you move this larger, it'll be more on top or more forward. If you make this negative or smaller, it'll be further back. So you might have to change this if you don't see your tiles appearing or if you see them hidden behind another object. So this Z is the depth. We're almost there. We just have to pass in our rotation and our parent, because if we have these two parameters, we can't just leave them blank. Okay, so for rotation, we can just get the rotation of the board and set the rotation of the tile to be the exact same. So what I'm going to do is right click in anywhere and add a new unit. And I'm going to search for get rotation. Make sure you select the transform, not any other one like random or rigid body. Make sure you select transform, which means we can store a rotation of an object. The object is going to be this, which refers to the game object that the graph is attached to, which is our board. So we're just going to get our board rotation, and we're going to pass that as the rotation of each tile. Okay, there we go. And finally, we have the parent. We want the parent to be our board. So this we can actually select from our scene, because we're never going to delete our board from the game. But just take note, be careful here. If you ever delete your board from the scene, then your graph is actually going to break. So you could make the board into a prefab, but then you have to make sure it exists in the hierarchy. Okay, so just take note of that. All right, there we go. And now we can put this to the test. We can press play and we can check out where our tiles are generated. So just go into the game view and look at this. We now see a whole bunch of white on our screen. And if you go into scene view, you can see exactly where the tiles are. Okay, so here you can see each tile. You'll notice in the hierarchy, you can see the tiles as well. We have a whole bunch of tiles and they just have the name clone after them. All right, so we have 50 of these. And if you click on each one, you can see their position. You can also use the arrow keys to quickly jump through and see where all of them are here in our game. You can just click on them and go through. Okay, so you'll see all of our tiles were created. Now you'll notice they were created slightly off center, so all we have to do is just change the position of our camera again so that our tiles are centered. So in our hierarchy, we're going to select our main camera, and we're just going to drag it over a little bit to the left. Okay, then we can press play again, and you can see, okay, there we go. Here are all of our tiles. I want to just drag it a little bit over to the right and test this out again. All right, so let's hit play and just wait for it to reload. Okay, there we go. That's more or less centered. If you want to get this perfectly centered, all you have to do is, I'm in play mode right now, okay, and I'm going to center my game while I'm in play mode, because then I can see all the tiles, right? So I'm going to go into the game. Now it looks perfectly centered, but because I'm in play mode right now, I'm actively in play mode, all these changes I made are temporary. But I made those changes so I can now see what exactly was the position of my camera. Okay, my position was 2 on the X and 4.48 on the Y. So when I press stop, I want to go back to the camera and I want to change them to 2 and 4.48 on the X and Y. Now, because I was out of play mode, the changes were permanent. So if I press play again, I see my changes were preserved. Awesome, and look at that. We have a bunch of tiles on the board. Okay, so we were able to create these dynamically instead of having to do it manually. And we learned how to use here visual scripting for that. Okay, coming up next, let's continue our project. Now that we've created our tiles, let's go ahead and generate a puzzle image. So we're going to use an image that we cut into 50 different pieces. And it doesn't have to be 50. You could have fewer pieces. For example, if you wanted only 10 pieces, you just have to adjust the position of each piece. Because if you have 10 pieces, they should now have a position of 0 multiplied by 5, because they're going to be 5 times larger if you have only 10 instead of 50. So it all depends on how many tiles you have. But if you want to have each tile be at each of these indices directly, then you have 50 tiles in total. And you have 50 puzzle pieces. So coming up next, we're going to create puzzle pieces. So we'll just take an image and we're going to cut it into 50 different pieces for the game. Then we're going to fill the board with those little pieces of the total puzzle, and we'll fill it randomly. So it's going to be a little bit more challenging than what we've done here because we have just placed each of the tiles directly at an index. But if you want to actually place puzzle pieces, you have to introduce randomness. You have to place the puzzle pieces at random positions. So join me coming up next. We're going to work on filling our board with puzzle pieces. Hello everyone and welcome back to our course. Before we can fill our board with puzzle pieces, we need to actually get an image and make puzzle pieces out of the image. So you can find copyright-free images at pixabay.com or as well unsplash.com. There are many online sites that can allow you to find copyright-free images, so you don't have to worry about copyright. Definitely don't use any images that aren't free for commercial use. You'll notice here with the Pixabay license on these images, they're free for commercial use and there's no attribution required. So you can either find your own image, or you can also use the image I will include for you in the source files of this section. You can find those at the last lecture of this section. There will be a source files folder, and I'll include for you the image that I'm using and also all of the puzzle pieces that I made out of that image. But if you want to do it yourself with your own image, choose any image. It doesn't have to be an iPhone resolution size. Then go to this website, postcron.com, or any other image splitter website. You could even use Photoshop if you don't want to use a website. Here we can split our image into multiple smaller images. All you have to do is select or drag your image file here into this little box. The image that I'm using is just called Night Sky. I've named it that, and it's this one from the free copyrighted site. Next here, you want to select the number of columns and rows that you want. In our case, for our game, we saw we wanted 5 columns and we wanted 10 rows. Okay, so make sure you have this. That is going to give you the iPhone or phone shape. And you can also click and drag the corners if you want to make each of the boxes larger or smaller. Okay, just make sure you don't go off the bounds. You can make this as large as you want. Okay, here we go. And you can also reduce or increase the size of the image. Now just make sure you don't go off the bounds. You want to make sure, let me just reduce this again. You want to make sure all 10 of your columns actually fit in the image. So let me zoom out here. And then I'm going to drag this. Remember, you don't want to drag your grid off of the image. Make sure it's still in the image. It doesn't have to be perfect as long as you have your grid fit inside of the image. Okay, so now we're going to take our image and split it into these 50 pieces because we have 5 columns and we have 10 rows. Just hit the button Split Image, and that is going to allow you to download a zip file containing your 50 images. So you can download that and you can just save it and open up the zip file. Okay, I can go to the zip file on my computer. Here is the zip file. You can extract all of these or just select them all and then copy them and paste them wherever you want. If you open one of them, you'll see they look like little squares. Okay, so your image has been chopped into these little squares, and each of these is going to be a puzzle piece. All right, so we have all these different pieces. Awesome, now that we have our 50 pieces for the game, join me coming up in our next lecture. We are going to learn how we can store these pieces in a game object and then fill the board with all of those pieces randomly. Hello everyone and welcome back to our course. Previously, we learned how to fill our board with tiles. Coming up in this section, we're going to learn how we can use visual scripting to actually fill our board with puzzle pieces. Starting off, we need to create a game object to store all of our puzzle pieces. So let's go into our hierarchy here. And we're going to create a new empty game object. I'm going to call this our pieces object. Okay, then we want to drag all of our tiles, all of those image files we have for our puzzle pieces. We want to drag them from our computer to our project folder, and then from our project folder onto our pieces object. So here in our assets folder, let's go ahead and we can create a new folder, and let's call this our puzzle 1 pieces. Okay, then we can enter that folder. Then you want to drag your puzzle pieces, all these image files, from your file explorer into that folder that we created. So you want to select Control A in order to choose all of those PNG files and just drag them right into puzzle 1 pieces. If you click on one of these images here, you can see it's a PNG file still. In the inspector, you'll see it's called a texture 2D. So a PNG is treated as a texture. Okay, we can see the texture type, the mode, and some more information about it. Next, before we can attach these textures to our pieces game object, we have to convert each texture into a game object. So to do that, we just have to drag each of these textures onto the game. And you'll notice they also are quite big. They're bigger than the standard 1x1. So we can just resize them, and we'll do that all at once for all of our pieces here. First, let's drag them all onto the game here. If you go into your hierarchy, you can see they all appear. Okay, and let's just do that for all 50 here. So 19, 20, 21, 22, 23, 24. Sometimes if you try to do them all at once, you are just prompted to create an animation, but we don't want an animation from these. We just want them all to be converted to a game object. Okay, so I have 30, almost there. The fewer textures you have, the faster you can obviously create them here. If you have any animation that you accidentally created or controllers, just delete those. We don't need any of those. Because you have a lot of textures at once, sometimes it thinks you want to create an animation if you add them all at once, but no, we just want to add them. Okay, so there we go. We have all 50. You can delete any animations there. Okay, so just verify that you do indeed have all 50 in your game. Okay, you can also select all of them and then see how many you have in the top right-hand corner of the inspector. We have 50. Great, then we want to drag those onto the pieces game object here. Okay, so now they're all children of pieces. And we want to resize each of these tiles just to make sure that they're all 1x1. Otherwise, they're way too huge. So let's go ahead and select all of these, and we want to scale them down. Okay, so we can choose one of these, and let's see. You can scale it down until it's exactly 1x1. Okay, so let's just go into the scaling tool right there, and let's bring it down until it's about 1x1, because then we can see exactly what the scale is. Okay, it looks like it's slightly bigger than it's 1x1 here. So you can make it smaller. Let's see, we have here 0.61 by 0.61. Okay, let me go ahead and make that smaller. Let's do 0.5 by 0.5. Okay, here we go. Now it's a little bit too small. So we want to make sure it fits inside of these borders. Okay, great. So this line here, that's just a board. Great, so it will fit into the square. Let's see, let's do 0.55 by 0.55. It's a little too big. Do 0.52 by 0.52. Make sure you keep it as a square. Okay, great. 0.52 is the magic number. So I'm going to select all of these pieces here and change their scale to 0.52 by 0.52. So that means they're all now 1 unit. Okay, so if I select one of these and drag it out, I can see it's exactly 1 unit, or it should be exactly 1 unit. Let's see, that looks a little bit large, so let me just see what went wrong here. Because they should all be the same if they're all at 0.52. So let me just drag this over. Okay, that's a perfect fit. What about this one? This one should be the same. Okay, none of them should be bigger than the other. They should all be the same. So let me see if I line this one up. It should be exactly the same size. Okay, great. So they are. Perfect. Okay, so these are all the same size. Great. All right, so now we have our pieces game object. We want to turn this into a prefab because we don't want our game to look like this with all these pieces everywhere. We want to turn this into a reusable game object so we can delete it from the game and spawn it via our visual script. So I'm going to drag out my hierarchy a little bit higher here. And that way I can then drag my pieces object directly into my prefabs folder. Okay, so now pieces is reusable. So I can just delete it from the game and easily pop it back in. And don't worry that they're all over the place, the pieces, because we will be taking all of these pieces and putting them in the correct position via our script. So don't worry that they're a mess right now. That's totally fine. The whole point that we want is we just want each tile that we had as a PNG, we wanted to convert them all into a game object and put it into a reusable prefab. Okay, so now we can delete pieces from the board. Okay, next up, we want to select the board. And on the board, I want to have another variable. This is going to be the variable that represents all of my pieces, because then in the script for our board, we can then write out our script that's going to use that pieces game object to choose a random piece from all of the pieces and put it into a random spot, and to do that with all of the pieces. So we're going to just take all those pieces and arrange them randomly on the board. Okay, so we could even just have the game start off with all the pieces everywhere. You could do that. That would be a lot more messy, but it's definitely an option. You don't have to arrange all of the pieces perfectly on the board, but we are going to learn how to arrange them all perfectly. Okay, so let's go into our board and let's create a new variable. Okay, and this is going to store all of our pieces. So let's just call this our pieces variable. Okay, then I'm going to hit enter. Okay, feel free to make it capital or lowercase. Here, then we're going to create the type. The type is going to be game object. The value here is going to be from our assets folder, and it's going to be the pieces prefab. Make sure you're using the prefab. Do not use the object or the prefab in the scene. It has to be from the assets folder, because if it's in the scene, that means that if you delete the pieces game object or prefab from the scene, then you'll no longer be able to use it in the graph. The graph will break. So you have to make sure you're selecting the pieces prefab from your assets folder, which is permanent because it's your project folder. Great, so now we have a reference to pieces. This means that we can put that to use in our script. One more thing I also want to do in our hierarchy, I want to create a child object for our pieces. So I'm just going to create here a new empty child, and let's go ahead and rename this. So I'm going to rename this. We'll call this our pieces container, because currently you'll notice if I spawn or I press play, all of my tiles are spawned, and I don't want these tiles to be spawned amidst the pieces. That's why I'll have this pieces container, just so that we be organized. All of our puzzle pieces will be inside of the pieces container. You could also do the same for tiles. You could put all the tiles into a tile container. Okay, great. So we have our pieces set up. Next up, we'll have to write some visual scripts. So we're going to create the visual scripts in order to spawn our tiles or our puzzle pieces. And then after that, we'll also have to make sure that we never repeat a piece, because we can't have duplicate pieces. All the pieces come together to make the puzzle. So each piece has to be selected randomly one time and then never selected again. And then also, often we'll have to do some adjustments to each of the pieces. Like you'll have to give them a collider and a rigid body, so that way they can actually be processed for movement. You can move them around with your mouse or with your touch if you're on the phone. And then we'll also have to write the movement functionality, so that way the player can swipe and they'll be able to move the pieces by swiping. And then we'll be good to go. So let's go ahead and join me coming up in our next lecture, where we're going to put our pieces variable to use. And we are going to randomly spawn our pieces on the board. Hello everyone, and welcome back to our course. Previously, we learned how to take all of our PNG textures for each puzzle piece and put it into our Unity game. Coming up in this lecture, we're going to learn how we can randomly place these pieces on the board. It will be similar but slightly different to how we placed our tiles. First, we're going to place pieces at random, and next, later on, we're going to learn how we can make sure we never repeat a puzzle piece. So join me back in our project. We are going to go into our scene and go to our board. Here, we are going to write a new graph that will be part of the generate board graph. So let's hit edit graph here. Okay, and next up, we want to create a custom event. That custom event is going to occur again at each of the positions available on the board. So we're going to continue on using this nested for loop system. After we've instantiated a tile, we then want to generate a random puzzle piece. So let's go ahead and drag a new executable node here, and I'm going to search for an event. Okay, and I want this to be a custom event, so let's do event trigger. And let's see, we want to have a custom event being triggered. So let me search here, custom event. Yes, we want to use here trigger custom event and hit enter. Okay, so this is going to allow us to create our own event, and we can then trigger that. And the reason I want to create an event is so that I can separate my functionality here. Into this string parameter, we pass the name of the event. Let's call our event generate random piece. Next, we actually do have to create the event generate random piece if we want this trigger to work. We could create the event right here in this graph, but then that would be a lot of nodes in the graph. We're already getting quite full here. So instead, I'm going to create what's known as a super unit, which is a graph within a graph. Okay, so let's right click anywhere in our graph here, and I'm going to search for a super unit. There it is in nesting. Then you can double click on this super unit to open it, and you can see it will appear in the top left hand side beside your board. You can go into information about this, and let's call this super unit generate random piece. Okay, or generate piece. We can also add a summary if we want. And again, we have inputs, outputs for trigger and data. This is just like a regular graph, but it's just nested inside of the board. Okay, so you can go back to the board anytime by clicking on it, and then go to generate piece anytime as well. You can also create variables for this graph, this super unit. So here, inside of this super unit, we are going to create our custom event. So let's just delete these default input and output nodes. So I have to create the event that I called generate random piece. So let's go into our super unit, and it's just making our setup cleaner, because now instead of throwing everything into one graph, we're separating it into two graphs. Here I'm going to right click, and I'm going to create a new custom event. So instead of trigger custom event, make sure you select custom event, because we're not triggering an event to happen, we're actually creating the event itself. So it's a slight difference, but you have to be careful. Then we have to give our name. We have to give this event a name. We have to use the same name we already used, generate random piece. Why do we have to use that exact same name? Well, because that is how this trigger node can find what event it should do. It uses the name here as how it finds the event. So it's going to find this event, generate random piece, which we're creating right here. Okay, now how do we create a random piece? Well, first we need to choose a random child from our pieces. So if you go back into your board, you can see we created this pieces variable, and you'll recall that the pieces variable has a bunch of children from 1 to 50. Each of these is a child because it's nested underneath the pieces. So we can choose a random child from this variable pieces, and we can spawn that child. Okay, so let me just go back to my scene and then go back to my board and back into my script. Next, I want to choose a random child. So I'm going to drag a new executable node here, and I'm going to search for random range. Here we want to choose min inclusive and max inclusive. Okay, and next we want to hit enter to choose that one. This is going to allow us to choose a random number between a minimum and a maximum inclusive. What is that random number? That is going to be a random index of all of the children of my pieces variable. So first I need to grab a reference to my pieces variable. I'm going to go into my Blackboard here, and you can check out all of the different variables you have. Under object, you see pieces here, and you can just drag and drop that right onto the board. So now we have a reference to our pieces. Next, we want to get the count of all of the children in the pieces, because that will be our maximum. Our minimum index will be 0, and our maximum will be the number of children. Okay, so I'm going to drag this off here, and I'm going to search for get child count. Make sure you're under the transform category. This node is going to return the number of children the parent has, which in our case is 50, but we're using get child count, so that way if we ever change the number of pieces, it doesn't matter because we're always going to be counting. Okay, so we have our count, and this count, that is what we want to pass in as our maximum, because we can't generate past the number of children. So we're going to choose a random number from 0 to that last value. One thing to be careful about is this inclusive maximum. This actually should be an exclusive maximum because this child count is going to be 50. We have 50 children. If we generate a random number, it's going to be from 0 to 50. But index counting in Unity begins at 0. So actually the first child will have index 0 and the last child will have index 49 instead of having the first index be 1 and the last index be 50. So you have to be careful about zero-based indexing in Unity. So instead, let me just do this again. Let me choose here a random range. And this time I'm going to choose min inclusive, max exclusive. And I'm going to pass my child count as max exclusive. This way, we're going to choose a random number from 0 to 49 because the 50 will be excluded. We're still going to be choosing 1 out of 50 random numbers, but those 50 random numbers will be from 0 to 49, which is 50 different options. And again, the reason is that counting in Unity begins at 0. So the first child will have index 0 and the last child will have index 49 instead of the first child having index 1 and the last child having index 50. So be careful about zero-based indexing in Unity. Okay, now at each of these, we want to now instantiate a new piece. So after this random number has been selected, I'm then going to call instantiate, just like we did for our tiles. I'm going to choose instantiating using an original, a position, a rotation, and a parent. Okay, so what is the original game object that we're cloning? Well, that is the puzzle piece from our prefab. So what we have to do is we have to get a random child from our pieces using the random number we just selected. This range function returns a random number, And we're going to use that to select a random index from the pieces. So here I'm going to right click in my graph and I'm going to search for get child. Okay, and make sure you're in the category transform. So you can get a child of an object by passing in an index. For example, if I pass in index 0, that will give for me the first child in pieces. If I pass in index 49, that will give me the 50th child in the pieces object. Instead of always using 0 though, I want to use a random index, which I can use via my range function, because remember the range is going to return for you a random number from 0 to 50 exclusive. Okay, then we have the actual parent. The parent by default is this, but this is the board. We need to change this so that instead of using the board as our parent, we need to use our pieces variable as our parent. So I'm going to just drag off here another node from the pieces, another link from the pieces node, and pass it into that parent parameter. Notice that I'm not connecting this get child node via executable nodes, and that is totally fine. You don't have to connect one node via executable nodes. You could just connect them via the data nodes. That's totally fine, as long as it's connected in a meaningful way. All right, and this way we're taking our parent, the pieces, and we're getting its child at a random index. The result is going to be the child. So we can take the child and we can pass it as the original that we are using to instantiate a clone. So we're making a clone of a random child. And remember, the children are our 50 puzzle pieces. Next, we also need a position, a rotation, and a parent. So the position, we want this position to be the same position as whatever tile we left off at. Because remember, in the board, we are generating tiles at a position, and we really don't want to write all this code or write all these nodes again. So instead, what we can do is we can actually pass this vector of the position, we can pass it to our event. All we have to do is change the number of arguments that the event uses from 0 to 1. An argument is some extra information that you can pass to an event or to a node or to a function. Here we now have argument 0. What I'm going to do is use my vector 3 and pass it to that argument 0. This vector 3, remember, that is the position of the tile. So after we've created a tile, at that same position, we're going to create a puzzle piece. Okay, now be careful though, because in our event for the generate random piece, we also have to specify that the number of arguments is now 1, which means we can now put that argument 0 to use, and that argument 0 is the position of where we want to spawn our puzzle piece. So now we have our position. Next, let's do rotation. For the rotation, we can just get the rotation of our board, just like we did for the tile. Okay, so I'm just going to add a new unit here anywhere on the graph. This will be getting the rotation from transform. Make sure you're under transform here. And remember, this just refers to the game object that the graph is attached to, which is the board. So then I'm going to pass the board's rotation to the rotation of my puzzle piece. So it'll just be facing in the same direction as the board. Finally, we need the parent. What is going to be the parent of our piece here? Well, we want all of the pieces to be under the board and in the board's sub-object or child, which was the pieces container. So select the pieces container. Remember, we made that previously. Here in our hierarchy, we have the board and we have the pieces container. Just make sure you don't delete this pieces container. Otherwise, this node will break if you don't have the pieces container in your scene. Awesome, and that is all we need to spawn our pieces randomly. Next, let's press play to test out the game. You'll notice here in our pieces container, we now do have 50 different random tiles spawned. In the inspector in the top right, you'll see 50. But you'll notice some of them are actually getting hidden behind the tiles. Okay, so you can see the pieces get hidden behind the tiles sometimes. If you go to the scene window, you can click on one of the pieces, double click on it to zoom in on it, and then you can drag it over. You'll see it's just hidden there. So what we can do is either change the Z position of our pieces so that way they spawn on top, or we could just remove the tiles completely. So if we go back to our board, here we don't have to instantiate our tile anymore. We can just delete this node and instead go directly to generating a random piece. We can also remove this get rotation now. We don't need that either. Okay, so now we don't need to generate tiles. You can still have the tiles in there. You just have to change their Z positioning, make sure they are always going to be behind your pieces. All right, now if we press play, we can test out our project again. I'm going to go into my game view and look at this. We can see we have all of our pieces spawned. Now these are just 50 random pieces. Some of them can be duplicates. So coming up next, we're going to learn how to make sure we never duplicate a piece. So that way the player can move the pieces around to create the whole puzzle. As well, you could change the background color because now we don't have the tiles. To change the background color, just go to your main camera here. And in the inspector, you can change the camera properties here. All right, so what you can change is the background color from this dark blue. You can change this to anything you want, such as white or black, whatever you like. Let's do a white. All right, so now if you press play, you can see here we can have this white background. Okay, so all we had to do was just remove the project here in the board. We removed the node that created the actual tile. And we just did that by selecting the node and then pressing the delete key on our keyboard. Also, if at any point you want to break a link, you just have to right click on that link and that will break it. Okay, so just for your reference. Awesome. Coming up next, now that we know how to create different puzzle pieces, we are going to learn how we can choose random pieces without any repetition. So we'll just have to add more nodes to our super unit to make sure that we never repeat a piece. I will see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.